Thanks. Yeah, the voice is still not 100% there, but we'll get there. At least feeling much better than last week. Okay, great. Let me get into this. So tonight, basically, we're gonna start from topic 4, just the last part of topic 4. So that's the mathematics part. Yeah, let me quickly get the register in the link. Let me quickly see, where was it? Let me just get the link. I say, cool. The link is in there for you to complete the attendance register. So let's get going. So basically, what we're going to look at tonight is, again, just looking at the financial maths component. And then we will go into some of the new work in topic 5. So I'm going to quickly scroll through everything till we get to the mathematics, financial maths part. So, because what I included here is also a few examples, so that we can get the examples out of the way. I'll show you how to use Excel again for the examples as well, and then I will share Excel onto our WhatsApp group also later tonight or tomorrow morning, that you have that available as well. Okay, so we started off last time looking at simple interest. We also looked at how to work out a simple discount rate. We then went into compound interest, and then I think we nearly stopped at this stage where I showed you some of the compounding periods and what you need to do with it if I say it's annually or semi-annually or quarterly or things like that. So that is nearly, yeah, the simple discount file is an interesting one. So think of it as, because we don't really, like you say, we don't really see it in real life, but it can, thanks, Nadima. So if you think about it, because it's not really encouraged by banks, because it nearly says for you to pay off something quicker, you get a discount. So if you had a loan of 10,000 that you pay off monthly over 4 years, simple discount will nearly come in that you will get a discount if you pay it off over, say, 3 years. So in certain instances, institutions won't really want you to go for that, because that takes away from the interest they're receiving. So, but we're honest about that. So, um, but it might be that in other instances, so you can really look at it, and it might not be that the institution give you a discount, but you can nearly work out if you pay off a bond a year earlier, what your hidden discount would have been nearly. So that might be nearly a way to look at it. But simple discount, we're not going to really see it playing out in real life. So only in your assignments and in your final assignment as well, probably. Cool. So let's look at we also looked at time value of money where we looked at certain periods of time. So if it was for first period, the second period, or third period of payments, and then I think where yes, and that is nearly LZ. That is nearly how you can look at it in the true form of a discount. Again, it's you probably, instead of having an interest rate of 10%, um, they say you get a discount in it, but then you might pay 9%. But it is not really that that let's be honest, that you're scoring out of it. You're just paying less um, in that scenario as well. So what I thought was, okay, let's look at a few examples that you can see there's a few hidden there. But before we get there, one or two other things that we also need to just look at. So part of a financial um, subject or in this topic, we're also looking at annuities. And annuities is basically, if you look at any pension product. So if you look at, if you're working and you have a provident or pension fund at your work, that is an annuity. If you have bought a retirement annuity, or as they call it, RA, that's an annuity. So that's basically something that you put away on a monthly basis, and you will get interest on that, and then in a time period of a few years, something will be paid out in retirement annuities. It's basically when you retire, but there's other types of annuities that might have a shorter time span and things like that. Then, so let's look at the example. So, and I also want to copy this into Excel, because as always, I like Excel. I will now share my Excel screen with you. Just quickly want to make sure that we can see it. Okay, so I quickly stop sharing and then. Okay, so Excel. Okay, so here they tell us determine the present value. So we're going to look for the present value. We don't know what that is, so that is what we're going to look for. And let's just make it a bit, okay, not that big. Okay, that's a bit bigger so that you can also see. That provides R1,000 a year for 5 years. Okay, so we know an annuity is something that you pay in this instance per year, but it is basically a premium that will be paid. So is it per month, per year, whatever. In this instance, it is per year. I'm just putting that in for 5 years. So we've got our N. If the interest rate is 12.5%, so we've got an interest rate of 12.5%. So we need to work out the present value. Okay, so we can go to Excel. There's a nice function that is called present value. Okay, so present value, and if you look at what is needed, we need the interest rate, we need a number of years or the number in the period. So if it was monthly, we will just multiply by 12 again. We are going to put in a PMT, and then we know that because they say it will be paid out, your future value will be 0. So before we do that, I just want to make this a bit easier for us and for you to, when you use it, that you can just, okay, and let's put in the future value so that if there is a future value in the future, you can just add that in here in your formula. Okay, so let's go. Interest rate is 12.5%. I'm just going to change that to percentage now, just so that it reads it correctly. Your period is 5. Your payment is 1,000. Your future value is 0. Okay, let's just make that percentage. Then if the same with your financial calculators, we need to make one of the things a negative so that the value that you work with will be positive. Else, if that is kept positive, just remember that your final answer we want to make a positive value. Okay, so what we've got is determine the present value of an annuity that provides R1,000 per year for 5 years if the interest rate is 12.5% per annum compounded annually. So what one can look at is, so we had 5 payments of 1,000, so that is about 5,000. But this is the present value. So your present value will always be smaller than the amount that you will be getting out, because you are getting interest the whole time on that present value. Okay, so this is just a way to work out the present value if we needed to. If we needed to say work out the future value, I'm not going to do it now, but there is also a future value formula. Okay, which again, exactly the same information. You put in the rate, you put in the times per year or how many times it happened, your monthly, yearly payment, and then your present value would have been 0. So very similar happening if you need to work out the future value. Okay, so this is one example. You could have used your financial calculator as well. And with a financial calculator, what you would have done is in a very similar format, you would have said, and depending on which calculator, my HP I would have done by going into BMT would have been minus 1,000. What I normally do is also, I will make the future value 0. Just, yeah, just because sometimes if there's a few questions on the financial maths, and it might be that in the memory there's still a future value of a previous question. So what I normally just do is to just make 100% sure that it doesn't remember one of my previous questions. I make the future value 0. Then your interest rate that you will put in will be the 12.5%, and the last one is your N, that will be 5. Normally your calculator, and again, just check there's a payments per year. I would change that to 1 just for this instance because it's annually. The default is normally 12. So just be careful that the default is normally 12 because one assumes the annuities are a monthly thing. So just check that you make it that the payments per year is only 1. And then the next one is to just calculate your present value, and you will get exactly the same answer. No, so exactly. So on your HP, you just type in 12.5. You don't use the percentage because it sees it already as a percentage. So yes, and that's why originally I put in my Excel 12.5 because I'm so used to only putting in 12.5 in HP. So yeah, one of those things that just again make sure that when you switch between the two, that you know which one to use. Okay, so that was a present value one. There is more coming, so don't worry. And then the other thing that you guys will get in one of the assignments is amortization. But nearly how I like to explain it is there's the payment in the table. So I would always, even if it goes into 20 years or whatever, I would just draw up the first 1 or 2 years just that you see what is happening. So your payment here is that you will work out the PMT. So if I know my outstanding value, and I don't know if okay, so there is the 15%. So let's quickly just go and, so it's 5,000 Rand. It is for 5 years. It is 15%. So let's get a PMT. So I'm just opening up a Excel again. I will share it now with you. So let me quickly. And let's make it, hopefully, why does it get bigger? Cool. Okay, so we've got, they told us there's a present value of 5,000. Then they told us N is 5 years. It is yearly, so we can work with that. The interest rate is 15%. And let's just make future value will be 0. And I'm going to work out a PMT. Okay, so again, very easy. There's a PMT function. And I think that is what's nice about Excel as well. It's not called something weird. It is as we reference it in any case. So we reference it as PMT. So they made the function as easy as that. So the interest rate we said was 15%, the times per year, or it was for 5 years. Present value was 5,000. Future value is 0. And there we have a 1491.58. Okay, so there we have the payments per year. So then if we go back to our slide, you can see that was the payments. So basically what we need is the interest. The interest here is interest on 5,000 Rand. So it is 5,000 times 15%. So if we do 5,000 times 15%, we get 750. You see there is a 750. So what now happens is that we need to calculate the principal repaid. So how we do that is 5,000, or let's rather take that out. It is the payment, so the 1491 minus 750. So 1491 minus 750 will give you that principal repaid. Then that principal repaid is 741.58. So there can be two things that I've now not included here. So you can add another column here to say end of period. what will happen just is you can say the outstanding minus that principal repaid will be your new outstanding amount. So you can see 5,000 Rand minus the 741.58 will give you your new 4258.42. Then the next step is, again, we need to work out the interest. So now on that 4258.42, on that we now need to work out 15%. So suddenly your interest rate or your interest comes down because your outstanding amount is less. Then because that is less, suddenly your principal repaid, you will see, is becoming more. And that is nearly how, again, you can think about this in anything that you take out a loan for. So if you take out a home loan or a car loan, doesn't matter what, they will always say you pay nearly that first few, on a home loan, nearly the first few years, it's nearly only interest that you're paying. So you can see here that we, as we go down with the interest, or as you go along the years, the interest that you're paying will become less and less and less. And basically, the amount that you're paying on your repayment is becoming more and more. And that is how it happens in any daily life situation as well. If you look at your payment. So again, that is why nearly they always encourage that on loans and those kind of things, you try to pay it off earlier so that you can nearly pay off quicker on the interest part than just waiting for it. So yeah, so this is basically amortization, but it nearly, you can look at it as a very simple way of looking at how your home bond or any other bond that you take out, how you can calculate what is happening in that situation. Okay, so let's go into some more of the questions, and this comes from some of the previous well, not, it's been a few years ago, one of those assignments that was done before everything went online. So again, giving you bits of information, and you nearly need to work out some of the other things. So they tell us that 5,000 is invested. So we've got the present value. They tell us it's simple interest. So simple interest, you can't really use your calculator's formulas, because that is automatically set as a compound interest. But we know what the formula nearly looks like. So for simple interest, it is something like this. So we know what the interest rate is. What is the amount that will be received at the end of a period? And we know that they tell us it's for 5 years. So we know it's for 5 years, and we need to work out the future value. So in this instance, I think very straightforward, unless, yes, please. Yeah, try. Um, okay. Okay, so there was a few that, am I back? Hi guys, can you hear me? Oh, cool, thanks. Load shedding and the system did not come back into rebooting. So yeah, but at least I'm back now. Um, yeah, I'm used to that everything automatically um, is back and running. Okay, so let me just get back to the slideshow and share that again. And just make sure this is still recording. Perfect. Okay, so spot on. So the 6875, spot on. Um, so yeah, great stuff. So I'm gonna give you the next one also to first try. Yeah, you want to make an investment at a bank, again, at a simple interest rate of 10% per annum, that will yield an amount of 6,000 after 4.5 years. Determine the principal to be invested. Also calculate the interest. Okay, so but first we want is that principal that we want to invest. Okay, so again, try it. I'm gonna put in a few things in here so long that can assist you. So we know that the future value is 6,000. We know that your interest is for 10% per. Oh, come on. After 4.5 years. See why I can't put in my 4.5. Okay, so what did you guys get? Uh, we've got Carl with 4137. Don't worry. Um, so let's see if Carl was right. Okay, so on the first part, yes, perfect. 4137. So Carl, you got that right. And then if you then need to work out what the interest was, it's a very simple calculation of saying the value was 6,000, and basically you worked out that it would be 4137. So if you just subtract those two, you will get that value in the end of 1862.07. Okay, so that is if you needed to work out the interest component. Okay, let's, sorry about this connection tonight. So let's see the next one. How long will Lucy have to wait before her 2,500 invested at 6% simple interest per year accumulates to 3,100 Rand? Okay, so here we have a the beginning of 2,500. We've got the interest, which is 6%. We've got the end one, which is 3,100. And we need to work out how long. So this one nearly looks at it from a different angle that we had the one that we needed to work out the present value. Now we have the one, or we had the one for future value. Now we have one that we're using the same data, but we will need to work out a term. Okay, so Kyle says 4. Any other takers on this one? Okay. Okay, so let's first, before I open up so let's look at how your formula would have been. And I think that is important. So your future is equal to your present times 1 plus interest times n. Okay, so we know what S is. So we can rewrite this formula a bit different. So if we write it S divided by P, that will give us something like S divided by P is equal to 1 plus I over N. Okay, so that we can do. Then I'm using a bit of maths. So, okay, so let's try what is 3,100 divided by 2,500. Okay, 1,24. And that is equal to 1 plus IN. Okay, so then we want to make this a bit simpler. So I will first take 1 away on both sides. So to do that, I need to say on the left-hand side, I subtract 1. If I subtract it on the right-hand side, that will disappear. Okay, so now we have 0,24. And then I want to get rid of the interest component. So to get rid of that, I divide on both sides with I. But we know that I is equal to 6%. So then if you say 0,24 divided by 0,06, you will get N is equal to 4. So Kyle, well done. And here is just another explanation how they did it. So you can all work with the original formula, or you can go to the interest component and work from there. Cool. That, let's see if I can copy that and I'm allowed to paste it on here. So let's see. Okay, cool. Uh, let me crop it. Okay, so I'm just going to put it here, but you have it as well. Thanks, Carl, for that. Yeah, I think this is a very nice one that you can see the differences in how to get to certain. So if I ask you to work out the S, what you need to do. If I ask you to work out the N, what you need to do. Um, thanks for that. Oh, okay. Page 235 in the study guide as well. Okay, then one last one for financial maths nearly. So how much interest is earned on 9,000 Rand invested for 4 years at 12% per annum, compounded annually? Okay, so as always, love to do the timeline. It just helps to when you need to look at what you need to get to. So the things that we have in this one is we've got our P. So now you can use your financial calculator as well. We've got the 9,000 as a present value. You got your interest of 12%. You've got your period as 4 years with no monthly or additional payments. So what is our future value? Okay, so here again, you can use your financial calculator, or you can go to Excel. So what I'm just quickly adding another spreadsheet to and I will share it now. Okay, so cool. Thanks for that. Let me quickly share the spreadsheet. Okay, so and let's make it a bit bigger. Let's do that, and then we can make it bigger. Okay, so again, they want us to work out present value. There is no payments per month, so we can change that to 0. Sorry, we wanted to work out future value. The payment per year, we started off, sorry, with 9,000. So let's do that. It was for 4 years, and I think it was for 12% interest. So future value, got the rate as 12%. We've got it as 5. We've got no payments. got the present, and there we have it, 14,164. And I think that is what you also had in one of the, yeah, 14,161. And if we take away that block, you can also see where is the 14. And again, interest if we needed to work it out. Okay, again, your interest will then just be the 14,161 minus what you started off with. Okay, so that is the part of the financial maths part of looking at annuities, looking at some of the simple interest. I will also look for one or two worksheets that I have that might be of assistance for you on this as well. What are your as I just open the next one, your next assignment, what is covered for your next assignment? Is your next assignment? Yeah. I lost track with being out of it for a week, so I'm hoping we're still on track with what you need to do. But I will still get you some worksheets for financial maths so that you, at least, if it's still one of a smaller, the bigger assignment will still cover that, and then we end. Okay, so basically what we've done today so far is what you need to do. So I will check for some worksheets for you. Even if it has answers, even better. Then if they ask something like that in your assignments, then at least you are better prepared as well. But yeah, let me get you worksheets. I'm sure I have somewhere in my archives. Okay, cool. So then we covered what we needed to do for your coming assignment, but let's also start looking at the next component, which is looking at stats. So we're looking at how to collect data, how to present data, and then also to look at some descriptions of data. So basically, we will probably not end or do everything tonight, but the next session we will end again on this topic so that it gives you time again for your next assignment to add that in. Okay, so on collection, presentation, and description of data, the things that I thought and that is important, and it's also in your study guide, is that we're going to look at the introduction of statistics. So we will so we will look at the introduction. So we will look at things like what is a population, what's a sample. Then we look at ways to collect data. So if we use simple sampling, randomized sampling, stratified sampling, so we'll talk a bit around that. Then how to present data. So it might be that, well, again, what will happen in your assessments is they can't ask you to present data because, again, it's multiple choice. But they can ask you it the other way around by saying, this is a set of data. Which one of the following is the right way of showing the data? So they can just flip it around a bit. And then we go into measures of locality. So that's basically looking at things like mean, median, and mode. So everything around locality. And then dispersion basically looks at how your data is dispersed. So is it very close to the mean? Is it far away from the mean? And how we look at that is few things like what's the range? We look at standard deviations, variances, and those kind of things. But that is nearly more to the end of this chapter. Okay, so what I've included as well is that there's, and I think also if I ask anything about definitions in any of these assignments, that's why I'll, even if we don't finish tonight, I'll already post this onto the WhatsApp group. Just that you don't need to learn the definition. So if I ask you what is, they say the following 4 or 5 things is about descriptive stats, and you need to pick one that's wrong. What I've added here is what is descriptive stats, just that you don't now need to go and worry about it or study it. The same with inferential stats, and we don't nearly go into that at all with your studies. We will only look at the descriptive stats. So we would look at summary measures. We would look at mean, median, modes, those kind of things. We are not doing any hypothesis testing or anything like that. That is for a stats course. That is not for what you guys are doing. So this topic will basically focus on the descriptive stats component. Then also just again from a theory point of view, if they ask definitions, they talk in the study guide about population, a sample. The easiest way to look at it is the population is the biggest set of information and the sample is a subset of that. Okay, so, but there is other things that is of interest just if I want to ask it. So for population, the measurable quality is called the parameter. How I would normally look at it is population goes with parameter. The two P's goes together, where for a sample, the sample goes with a statistic. Okay, so that's normally the easiest for me to remember it. The S goes with the S, sample goes with statistic, population goes with parameter. Okay, so that is if I ask you anything about a measurable quality. Okay, then if I ask you anything about what is a population, so the population is a complete set. Okay, so if we talk population of South Africa, everybody in South Africa, a sample of that can be the people in the Western Cape. Okay, so that is a sample of a population. What else does happen is reports are true representation of opinion. So when we look at population, because it's so big, it really is a representation of opinion, where with samples, we would normally work within a confidence or a margin of error. So what we will normally say is this sample gives us a 95% confidence that it is very similar to the population. So all that is saying is that we are 95% confident that the sample looks like the population. So that is where we bring in things like confidence intervals or margin of errors. Then in a population, again, linked to the complete set, it contains all members of a specific group. And then the sample is just a subset of that population. So again, something like students in the Western Cape could be your population. And a subset of that can be students doing QMI. So again, it doesn't represent all the students, but it represents a certain group of students that is representative of the bigger set of students. So that is just nearly looking at population and sample. And now that I see that, this should actually be population and sample and not population as a sample. So nice that I can quickly change it while we're chatting so that when I send it on, you will also get the right one. Okay, so population versus sample, again, where they might ask it is in a definition kind of way, and you have it now. You don't need to go and study it or look for it elsewhere. Okay, then the next one is, and let's even make it bigger so that is types of sampling methods. So again, when we talk about the sample is a subset of the population, we still need to get that subset. So we can use different sampling methods. Random sampling is basically you get a list. So if we use, say, Excel, you basically say on Excel, and let me quickly see if there is actually, so in some of the analysis tool packs that you can download, there should be something like a random generator. Let me quickly see if it is in one of these things. Okay, so I'm just quickly gonna show you. So let me share again my Excel spreadsheet. And this now will vary between Excel packages, and if you're working on a work laptop, might be that they haven't installed a lot of things for you, but there's things that you can download. There's a nice data mining one that you can download. There's a nice mathematical solution one that you can download. I'll actually show you that now. That is actually very cool. There's also a nice one that I will share. It's an app that you can also download, but for this one, say we go to data analysis. There's the data analysis one, and now I see it doesn't pop up. So to see why it didn't pop up. Okay, so strange. It's one of those small things. So I'm gonna do a print screen and then just quickly add it in here. So when I went to data analysis, it popped up this window. And if you then scroll down on there is a random generator function. So again, Excel is very, very nice in having things like that. But while we're now talking about, please check in your different, if it is in, it was on the home tab. So it was, so let me quickly, where did I include that? So there's the data analysis one. It's there on hopefully it's there on your home page. If it's not there, what you can do is if you go to data, there on this page you will be able to add. So you will be able to or go to insert and add the data analysis toolpack, or you will be able to go to one of these functions and add it. Okay, then the other one that is math solver. Let me just quickly so it's all math solver or math solver. Very nice app. So what it does is that it allows you to take a picture of a question. So for you guys that also had where you needed to work out two equations maybe, or if you need to solve for X, you can download the app, take a picture of the question, and it will solve it. It even goes into, I think, differentiation. I don't know about financial maths. Okay, let me quickly check. Okay, I don't see it on this one. I will check Carl out for you how to add it. Let me quickly just go to, Yeah, I'll check for you how to add it. I'll play around in it and check how you can add it. And then just go to the math solver as well. There is one in Edge that you can work with, but it's also an app that is downloadable. So if you guys don't get it, I will share later the link that I have with you on that. Okay, so the math solver will be less for the stats components. The stats components we will use Excel more often than not, because where we can work out the mean, median, mode, standard deviations, variances, all those kind of things. Okay, so with types of sampling, again, we're not gonna ask you in the assignment to do a random sampling or stratified sampling or system, but they can give you an example and say which sampling method is it, or they can give you a description and say which sampling method. Or what they can also do, and I don't know if it was in this one, but they can, where I now have this for mean and mode and those kind of things, they can do something like this, where they give you your different sampling techniques and they list characteristics of that. Okay, so there's a few ways that they can nearly ask you to work with a sampling. Um, they won't ask you to do a random number generator on Excel. Again, that's not going to make any sense in how they evaluate your answers and those kind of things. But sampling techniques or methods is very likely that it might be in a form of a definition. What I did was to put in a data set, and just some things around the data set. So here they tell us the city has so many medical practitioners. Then a random sample of 15 medical practitioners were drawn. Use the following random numbers to select the sample. So the first step is to number the medical practitioners. So we know it will be from 1 to 858 or 853. Since the total number of elements in the population is 853, a number bigger than that is obviously of no use. The sample will be consistent of a medical practitioners whose numbers are drawn. The first number is 4 times it. Okay, so the first number drawn is that. Okay, so the first number drawn is that. Then we know that 283, or sorry, 853, 283, sure, 853 is the maximum. So if we get a number of 872, that's not going to work. So our next number is 489. Then our third number is 230. Then it is 313, 287. Okay, 875 is bigger, not going to work. 844 is going to work. See, so this is just showing you what you would have done, but again, very difficult to to nearly ask that for you in your types of assignments to do that. So 134 would be next. Year 794 will be, and then 898 will not be an option. 910 will not be an option. And then you just continue plotting the number until you have your 15 numbers. And that is how our simple random generator or number generator will work. Normally what will happen is that, so in Excel, you would actually say, I don't want to go bigger than 853. If you look at online, you can even do that as well. So you can even just Google online number generator, and you will get a few options. And all of them will nearly have that you will stop at your maximum, because it doesn't make sense actually to have 872 because you will just ignore it. So why go up more than that? So you will nearly stop at 853. Okay, so this is just a simple way of saying if there was something that they give you, they might have this kind of flow, and they might say you need to complete, or what's the numbers for A, B, C, and D, and give you like a few options, and you select the one that is correct or incorrect or something like that. But else, not really anything else that they can ask around the sampling that is not a definition type of question. Exactly. Um, so, and that's probably why they will also not ask it, to be honest, Kyle, is that in something like this, um, unless, and it's, unless they just want to test that you understand that I would have done, if it was me, I would have had something like this just to test that you understand that 872 is not an option, because that is nearly testing if you understand what the random sample generator is doing, more than writing down the other numbers. That is actually making you understand that you can't have a number that is 872, because again, it just doesn't make sense. So yeah. Okay, cool. Let's go to the next one, because a lot of, oof, okay, that is very small. Did I even, okay, I'm quickly gonna duplicate, and let's see if it's at least a bit bigger. Okay, hopefully you can see it. Let's quickly see if I can. Okay, so that's made a bit bigger. Okay, so something again that probably not gonna happen, but let's just make sure that we cover it. So they can ask you, so they give you information about students, they give you information about faculty members, and then they ask you nearly to determine the sample size of each. So if you would need to select a certain sample, and I'm just going to randomly say, I want us to get a sample of 15. So if we need to get a sample of 15, how are we going to split it between 25 students and 10 faculty members? So I only want 15. How are we going to split it? So basically what we will do is say, well, in total, I've got 35. So students, there's 25 of them, divided by 35 times 15. Okay, here I said 6 members. So when you get it, um, the answer sheet will just refer to 6. We're doing it now for 15. Okay, so 25 divided by 35 times 15 gives us 10,7. So I'm going to round it off to 11. And then faculty members, there's 25 out of 10 divided by 35. That I will also multiply by 15. And here I will get something like 4 point something, which I will then round off to 4. So then if I needed to look at my two stratums, were students versus the faculty, I only can sample 15, then at least I need 11 students and 4 faculty members, then the sample will be representative of a bigger population. Okay, so this can be different in other setups as well. So what my job is research. So what we normally will do is to say, okay, we've got a sample, we want to focus on Gauteng, Western Cape, KZN, and Eastern Cape. We can only get a sample of 100. So how are we going to split it? And then we will look at the populations of each of the provinces, do exactly the same method. We will say, well, in the Western Cape, there is, and I'm making up some of these numbers, let's say 1 million. In total, there is 15 million adults that we want to target out of 4 provinces. So 1 divided by the 15 is the ratio that Western Cape can be. So that 1 divided by 15 times 100 will give us the sample that we need to recruit for the Western Cape. So this is actually used much more in practice than a random sample. A random sample that can happen in practice is where we all enter a competition and they throw all our names into a pot and randomly they pick one number, or they pick one, they spin it again, they pick another one. So that is more random. Lotto is supposed to be random. So it is supposed to be random, that every number, how it's picked as a random probability. But now we're going into probability and not. Yeah, I think some of conspiracy theories. But no, um, it is random. So obviously there's conspiracy theories about if certain numbers come up more regularly than others, but it is random. So that is why your chances of always getting or winning the million or whatever is 1 divided by how many, because it is random. So I'm just making my own conspiracy theories. Okay, so basically we've looked at this one part. So what also can happen with this is they can, now that you've selected your data, they can ask you a few things. So they can say, well, certain of the numbers are students, certain of the numbers are faculty members. So which one is a student or which one is a faculty member? But again, I don't see them going into this detail, but I have also added the answers to that for you. Okay, the next component is, and let me just get it back to 75%, is we're looking at presentation of data. So with presentation of data, the first thing we need to nearly identify is, are we talking about qualitative data or are we talking quantitative data? Okay, so qualitative data is things that the color of your eyes. So if we need to classify your color of your eyes, it will be blue, green, brown, gray, something like that. Another qualitative measure can be the rank in your years as a student, so first year, second year, third year. That can also be a qualitative. Quantitative, again, is something more that we count. So how old are you is a quantitative. What's your height, what's your weight, that is all quantitative. So it's something that you can count, or a lot of the times they say there's a number nearly associated with it, like it's 10 rand or 15 rand, or there's a temperature that is 30 degrees Celsius, or so that is more your quantitative variable. So you basically first need to distinguish between those two. Then the next step is nearly, how are we going to draw up a frequency table? I'm going to show you that. Then the other thing is how to draw and interpret a histogram. The same, draw and interpret a pie chart. So basically, these are all the tables that they can ask you. They love stem and leaf. So we will look into a stem and leaf as well. What I will also add and let me also just make a note for myself, a worksheet on presentation of data. So that, because how they like to ask this is, I might not have a nice example, but they can give you data, and then they present it to you. So they give you a data set, they present it 4 pie charts, and they say which one of this is correct or which one is incorrect. And they do the same with a histogram, with a stem and leaf, with a frequency table. So they love to ask it. So at least we've got time to, so that I can just get you some more things around that. The other thing that is important, so when we looked at qualitative, quantitative, we can split it another level. So qualitative can be split into nominal data. So like I said, the color of your eyes, which province you live in, that is all nominal data. But when there's suddenly order in your data, it becomes ordinal. So color of eyes, there's no order. If you have brown eyes, if you have blue eyes, if you have green eyes, that there's no order. But if you have an honors degree, a 4-year degree, 3-year, 2-year, 1-year, there's order in that. The easiest one to look at order is when you look at ranks of police officers or in the army, or even if you look in your organization, there might be a junior manager, senior manager, top manager, or middle management might be somewhere in between, and your CEO or something like that. So in that structure, there's order. So that is ordinal data. So that was with qualitative. The quantitative, the things that we said we can count, or is the number by, or things like that. We've got discrete data. So discrete data is something like 1, 5, and let's put it 5 Rand 20. Okay, so, and how they can ask it is, what is your height in meters or in centimeters? So then it needs to be 1,76 or 1,85. That is a discrete data. If, because you put it in discrete numbers, continuous data, and I think that is also important to, they can still ask you height, but they can ask you, or they can say, what is the difference in height of the students in the class? Sure, that can be anything. So unless they set height in meter, then we know it's a discrete number. So the same to say, how far are you staying in kilometers from your work or from UNISA? So then you would say, well, that's 50 kilometers, or that is 60 kilometers. But if I ask everybody that's online, how many kilometers did you drive today? Ugh, that is a continuous number. So we can look at the same measurement, but in different ways. And I think that is important for you guys as well. And where they might want to sometimes confuse you is by using some of it that you think it's continuous, but it's actually discrete, and the other way around. Okay, so can you guys see this list? So let me make it bigger again. Let's at least see if 100. Okay, so we can do the first, and let's make it even 125. See, that for me And Carl, now that you mention that, that is how I sometimes hate some of these subjects, um, because of English grammar. um, Being an Afrikaans speaking person, sometimes it does throw you. Um, and and that is, if I look at one of the other subjects on stats, that when we start with words of at least, at most, at this, then it becomes very difficult. And that is one of my nearly worries with a lot of, and with QMI as well, is sometimes the language that is being used makes it difficult. And if simpler language was used, it might be very simple to answer certain things. Okay, so let's quickly, length of a person. So I did not add how long it should be, so in meters or centimeters. So when it is a continuous quantitative, if I set the length of a person in centimeters, then it would have been discrete. Okay. Gender, it's qualitative. Okay. How many genders? We're not even going into there. So, but it is qualitative. There's no ranking in gender. You can be one of the genders, but it is qualitative. Now look at this. So number of customers in a store. So I know that in the store there will be 5 or 6 or 7 or 8 or 10. So that's why it becomes discrete and not continuous. I can't have a 1.17653 customers. I can have that in kilometers or in distance or in length of a person, but in customer numbers, I can only have whole numbers. So that is why it's discrete. Um, so what would you say if we look at duration of phone calls? Okay, so with that argument of mine that I said, I would also think it's continuous. Okay, so it is continuous. And then if you need to add the quantitative to it, perfect. Mode of travel to work. So what do you think mode of? I would also have gone for nominal because there's no order. Okay, so they just said qualitative, but if you want to go further, qualitative nominal because there's no order. Petrol consumption of a car. That's an interesting one.
Can you show the topic of I forgot what the headings are, the one with how much and how many?
Oh, okay. So quantitative, discrete, continuous.
Thanks.
Yeah, so the petrol consumption one is interesting. Huh. See, so I would probably also go continuous. Yes. So if I said petrol consumption in liters per kilometer, then it becomes discrete because then it is 5 or 6 or 7 or 8. But because we don't know, it is continuous. Okay, size of soccer crowds.
I'm
Yeah,
not sure if this one.
I would have also gone with discrete. So, yep.
In this case, does this mean that like you used earlier that we can't have 1.6 people in a shop? That was for continuous.
Exactly. So, and I think that is where you need to see the difference is with continuous, you can have numbers in between the whole numbers. So size of crowd, it can be a massive crowd. We might not know how many there are, but we know it is a discrete number because it's a whole number. Okay, so that's nearly the difference. So with petrol consumption, you don't know if it is 1.175 liters per kilometer or 10.7582, unless they said, what is your petrol consumption of liter per kilometer of your car, of a car? Because then by making it a discrete number. So that is nearly where when you need to look for these is nearly to say, okay, is the number that I'm looking at, is it a discrete number or is it a continuous number? So it's easier to say, is it a discrete number? So is it a whole number? So size of soccer crowds, whole number, discrete. Okay, does that help a bit more?
Yeah, that's perfect. Whole number was the word I was trying to get to it in my head.
Okay. Yeah, I think sure, we did that in topic 1.
Yeah,
I
it seems
think
like
we
10 years ago now.
Yeah, I think we did that in topic 1 where it was real numbers and whole numbers and we never thought we're gonna use it again. Okay, so when we look at the student exam center, I would have said exactly the same. Oh, what is qualitative? Qualitative. So why? Oh, so not number of student exam centers. Okay, this is an interesting one because I really don't know. So it's not number of, so that's why we can't go quantitative. So, so I assume it is more faculty kind of or names of exam centers, which make it qualitative. So we've got one in Paro, we've got one in Yeah, so this is a bit a stupid one because it nearly feels like there's not enough information in here to really say if it is qualitative or quantitative. I'll think about that one a bit more and come back to you as well. Okay, so it's definitely not quantitative because they didn't tell us number of or something like that. But I'll just go back and see what is happening here. Okay, number of cars, discrete. Okay, so that is, and then your home language. So home language will probably again be, I think, and that's probably linked to the student exam as well, would be qualitative, and if I ask us, it will be nominal qualitative. Okay, and that's probably why Student Exam Center is also qualitative, because one exam center versus for others. So yeah. Okay, so that is a way that they can ask you. What they might do as well is give you a sentence and say the number of cars sold by a dealer in a month, and they give you A, B, C, and D with a few options, and you need to pick then that it is discrete quantitative. So that is more how they would ask it in your assignments. Okay, this one I'm gonna ask you guys to practice, because yeah, I'm also gonna sign off now. So I'm gonna share this with you, and I'll share this information with you as well. But what I want you to do is look at all of these, and let's just quickly go back to 75%. So look at frequency table, look at the histogram, look at the pie chart, look at cumulative frequency, polygon, stem and leaf, and please try for all of this data set, nearly all those kinds of graphs. I'll do mine as well. Then you can always send it to me, take pics of it, send it to me on the WhatsApp group or per email. But then I think what I will do next time when we start, I'll show you how I would have done it. So that, yes, we're still going into, so here is a bit of information how to do the intervals for you, but nearly go and try it for all of the different techniques and see what you can get. Okay. Okay, so let's call it a evening. And let me just also stop. We will continue next week again with the rest of us. I'll